Okay, let's get this going. There are two ways that I know of quickly doing an IPSEC VPN. One of them is just like you enable IPSEC on the interface and then you match something called interesting traffic. And then the interesting traffic that you match is encrypted and sent across the network. And that's probably the one that I think we're going to see in the test. The second one is one where you embed IPSEC into some sort of tunnel, whether that's a GRE tunnel or whether that's using something called the virtual tunnel interface. Who knows? So let's just do the legacy VPN setup, the one that I've been doing for as long as I can remember. It's not the way you do it today. It's certainly not something that you would use in a live network today. But the legacy way is just one way of, I guess it's the simplest way, so it's the one the most likely to be asked to do. So I've got this lab here, I've got this quick lab. Now it won't look like this when we see the Cisco packet tracer lab, but the commands that I use and the way that this runs will be identical. So don't worry about that too much. So I've got this hub router and I've got these spoke routers. A, B, and C. Each network's got a separate subnet, and you can see I've tried to keep this simple. So 192.168/16 is the supernet, and then we've got these subnets, these /24 subnets in each branch, and then we've got the main hub here with this server in it operating in 10.1.50/24. All right. So I've done that on purpose. One, it shows separate discrete subnets and the way that we can match the interesting traffic, and it keeps the hub network completely different from the branch network, so we can see the routing working a little bit more easily. So I hope that's cleared that up. So we're going to configure the hub router first, then we'll do the spokes. What I'll do, I'll get some IP flowing between server 1 and PC 1, and once the traffic's going, we'll start hacking away, putting the IPSEC tunnel in place. The traffic will stop, and then hopefully when the tunnel comes up, it'll start working again. All right, so here we go. All the configurations are already done. So when we start the devices, I'll just quickly hop on server 1, all the PC nodes, and we'll do some pings end to end. So we should be able to ping server 1 to PC 1, server 1 to PC 2, server 1 to PC 3, PC 1 to PC 2, PC 1 to PC 3, and so on. Right. So all of those things should work, and all via the hub. All the routing is done via the hub. Okay, so while they're coming up, let's log in. Bring up all the terminals. I'm just going to move these around a little bit so we can see what we're doing. PC1, PC3, PC2. We've got the hub router, then the spoke router A, spoke router B, spoke router C. All the switches we don't need, so we can get rid of that. We can get rid of that. We can get rid of that. The switches are just there in case I wanted to add anything on, but I don't. So on server 1, let's grab an IP address from the DHCP server. And same for PC1, same for PC2, same for PC3. Okay, so they've all got an IP address. Now you can see 10.1.50.3, and that's in this 10.1.50.0/subnet. And PC1's got 192.168.1, PC2's got 192.168.2, and PC3's got 192.168.3. So everything's fine. Let's just do a ping, from server 1 to PC1, 192.168.1.3. And that's fine. PC 2.3, that's fine. 3.3, all right. So end to end, all good. Let's hop on router 1 then. The first thing we want to do really is define, well, actually, you know what, you can do this in any order. There's not really any magical way of doing this, but one of the most important things is matching this interesting traffic, all right? So when I say interesting traffic, what I'm talking about is the source and destination or the type of traffic that you're trying to match. Now, we don't care. I don't care too much about making this really specific. So I'm going to catch all IP traffic going from the main hub to all of the branches, right? But it's important to say that you can make this as specific as you need. So you could do host to host, host and protocol to host and protocol. So you could say web traffic going from server 1 to PC 1, or you could do, I don't know, FTP traffic going from PC 3 to PC 1. You know, you can make it that specific. That's your interesting traffic. And the way you define that is an access list. You can do this with a named access list or just a standard numbered access list, which is what I'm doing here. So this is an extended access list. I'm going to do access list. I'm going to give it a number. I'm going to say what I'm matching, permit IP. So I'm going to match all IP traffic, sourcing it from 10.150.0 all the hosts in that subnet. We could make it, like I say, we could make it really specific and just match traffic from server 1, that's fine. But I'm going to make this all of this subnet. And then where are we going to? We're going to 192.168.1.0, and again we're going to put the whole slash 24 in there. So all the traffic going from main hub to PC1's network. All right. What's next? All right, so the IPSEC tunnel itself. IPSEC is based on 2 phases. Phase 1 uses something called ISACAMP, and ISACAMP is a method of exchanging the pre-shared key, and all of the setup processes are called phase 1. So it's basically a key exchange, an authentication process goes on. So it's like, I am who I am, and you're my friend, and all this sort of thing. So it's basically the underlay of the IPSEC itself. It's something called ISACAMP. So phase 1 is where we're going to start. So let's do crypto ISACAMP, and then under here you've got a bunch of stuff. Now the new way of doing this would be using a policy, using a profile. Yeah, using a profile. But we're going to use the old school policy method, and we're going to give it a number. And then you hit return and you go inside this sub configuration. So you see how the prompt changed to config ISACAMP. And then under here you've got a bunch of options. Now these options, the way to remember the options that you need is using the phrase haggle. Like if you went to a shop and you were going to buy something and you were haggling with the vendor. I don't want to spend so much. I'll give you $10. Okay, I'll give you $8. And all this, so it's like you're haggling for something. And haggle is short for hash, authentication, group, lifetime, and encryption. These are the 5 key things that you would genuinely put inside this policy. Some of them are default and you don't need to worry about, right? So if you don't put anything other than authentication, this thing will work. Okay, but the five things that you want to put in here, you can change, and they're the key things. So let's start with hash. You got these options from MD5 to SHA-512, right? So SHA-512 is probably the best, okay, and MD5 is the worst. But we're in a lab, we don't care too much. Let's just use SHA, all right? So we'll use SHA. This is SHA-128. When there's no extension, it's SHA-128. So authentication. So under authentication, you've got these options. I haven't got an RSA server, so I'm going to use a pre-shared key. This is going to be a key that I define, and I'm going to share with the peer, which is going to be the owner of the branch A office, or probably just me, because this is me. So we do authentication pre-share, and we'll think of a key later. The next one is group, and this is the Diffie-Hellman group. Okay, so this is how it exchanges the key. This is the process for securely exchanging the key. And the Diffie-Hellman group from 1, which is the weakest, to, where are we, 24, which is the strongest, okay? Now again, I'm on a lab, don't tell too much, and you'll see in a lot of documentation people usually go for 2. So Diffie-Hellman group 2. The lifetime, this is the longevity or acceptable life period for this profile, all right? Now, I'm in a lab, I don't care too much, and it makes good sense to have multiples of this profile, multiple policies, with different lifetimes on, and then the router will time out and use a new key. Okay, time out and then use a new key. But we're going to have 1 key, so we're going to have the longest lifetime, doesn't matter too much. Finally, the encryption protocol that we're going to use. Triple DES, AES, and DES. Obviously DES is the worst, triple DES is the middle, and the AES would be the best. We don't care too much, we're going to go triple DES. Alright, so that's that finished. So that was the policy 1. But in the policy, you'll remember we did the authentication pre-share. So we need to set the key for this phase 1 ISACAMP authentication. So again, crypto ISACAMP, this time key. And we think of a key. I'm going to say Cisco because why not? And then you assign that key with the peer address. Now the peer address for spoke A over the serial interface is 10.1.1.2. Okay, so just to know. I probably could add that to this document here. Let's add a text. Let's say 10.1.1.2, and that's a /30 network. So this belongs here, and if I just duplicate that and put that down here, that is 10.1.1.1/30. Okay, all right, not very neat, but gets the job done. All right, I made that. Where to put it? Let's put it there. Okay, so the peer for the hub on this side is 10.1.1.2, and the peer from the hub on this side will be 10.1.1.1, but we're not there yet. So we've set up the ISACAMP. Next step is the IPSEC itself. So crypto IPSEC this time. And we're going to set something called a transform set. The transform set is the encryption standard that we're going to use. So let's give it a name. This can be anything. So we'll call it, you can call it TSET, you can call it whatever you want. I'm going to call it that, VPN TS. But it can be anything. Just think of a name. Remember it for later though. And this is the encryption standard we're going to use. This is the cipher we're going to use, I beg your pardon, for the encryption of the IP traffic itself. So this one has to be, this is the meat of the sandwich. So we need to put one in here. We're gonna use. So let's use triple des, because we used triple des last time. And you can put a bunch in here, and like the routers when they come online will have a good negotiation. Like, can you support this? Can you support this? Can you support this? Right? And that conversation requires the encryptions in the crypto standards to be in place on this line. So you can have one or you can have more than one. Well, let's have two, MD5 HMAC. And in here you can choose modes, tunnel and transport. The default is tunnel. That's the one we need. That's all we need. So that's the transform set. Now we need to do something called the crypto map. All right, the crypto map is what we use to bind all this stuff together. So again, let's think of a name. We'll call this VPN map. The transform set was VPN TS. The map will be VPN map. And you give it a number, a sequence. You can have multiple maps. Sorry, one map and multiple sequences in the same map. And a type. So this is an ISACAMP, IPSEC ISACAMP type. When you're in here, then you have to associate with the transform set. So we'll set the transform set. And we'll set the peer address. So again, this is the IPSEC. We already did for the peer for the ISACAMP, and now we're doing the peer for the IPSEC. So again, 10.1.1.2. This is spoke A's IP, and now we match the interesting traffic. So match address 110. Remember we created the access list 110, and that's it. That's really it. So let me just show all of the configuration that we did. There's one last step, but this is all the configuration that we did. We set up a policy. Policy 1, we gave it encryption triple des, authentication pre-shared key, Diffie Hellman group 2. We had an ISACAMP key, Cisco, associated with the peer address 10.1.1.2. Okay. We have an IPSEC transform set with this name, VPN TS, matching ESP triple des and ESP MD5 HMAC in tunnel mode. Then we have this map that brings everything together. We have the peer IP address of router spoke A. We have the transform set, which is listed here, and we're matching the address 110. And IP address and access list 110 permits traffic from 10.150 through to the subnet of branch A, and that's it. All right. So now the final step is to bind this to the interface. So you go onto the interface. Remember, this is the interface facing branch A. So this is this one here from router hub, and you simply crypto map VPN map. So the name of the map that you created in the crypto map here, crypto map. Now this is what you assign. Now when you assign it, you'll see that the ISACAMP actually goes from off to on, an off to on state. Okay, and before where we were pinging, and we could ping 1.3, we can no longer do that, because what's happening is the router's seeing this traffic, this interesting traffic, is matching that and trying to encrypt it and push it, but you can't push it because the tunnel is not up yet. Tunnel meaning the IPsec negotiation hasn't happened yet. So what I'm going to do, I'm going to put that in constant ping. So this is server 1 pinging PC 1 over in branch A. So we've done the hub. Now let's do the remote. Let's do remote spoke A. And we do everything we did in the last one. So the first step, let's do the interesting traffic. So we're going to permit IP coming from 192.168.1.0. So all the hosts in branch A's network going to server 1's network. All the hosts in server 1's network. That's the interesting traffic. Then we do the crypto ISACAMP profile, policy. Let's get mixed up. Policy 1. So this is the haggle thing, so hash MD5, Diffie Hellman group 2, authentication pre-share, lifetime was 86,400, which is the default anyway, you don't need to put that in. And the encryption, I think we use triple des. So that's that bit. Then we do crypto ISACAMP key, Cisco, address 10.1.1.1, so that's the IP address. Remember now we're going backwards, so we're going from spoke A back to router hub. So this is the router hub's IP address. That's the ISACAM bit done. Then we do IPSEC. We need a transform set. So we call this VPN TS. It can be a different name, doesn't matter. And we use the same encryption standards that we put on the other one. So I think we used triple DES, right? Let me just see. Triple DES and HMAC. Okay, so triple DES and ESP MD5 HMAC. And then we do crypto map, VPN map. We're gonna, one ISACAM. We do set, transform set. So we assign transform set. And then we do peer address, 10.1.1. And also, finally, we match the IP access list 110. Then associate that with the interface, crypto map. This should be VPN map. Hopefully IPsec should come on. And then, if everything's good, this should start pinging, but isn't pinging. It's a missed step. What did I do? Let me just see. So show, let's do some show commands. Show crypto ISACAM SA, shows if it's online. So it says it's in no state, and that's not correct. So it's trying to come up, but it's not quite making it. Let's have a look at the running configuration. So we've got this key that looks correct. We've got this triple DES MD5 pre-shared group 2, triple DES. Aha! So I don't have the MD5. So under the ISACAM policy, we're not going to have hash value. So the default maybe isn't MD5. Let's do that. Let's put that right. So crypto ISACAM on the right one, yeah. On the right one. Yeah. Crypto ISACAM policy 1. Hopefully I can just pop straight in there. Hash MD5. So now the hash value should match. Let's see if the session came up this time. So now the session is still in a state. Oh, there you go. So QM idle. So this is quick. QM means quick mode. So quick mode, and it's idle, meaning like it's negotiating now. It's just hanging around. We should have some pings. Now we've got some pings. So there we go. So that's it. I mean, that's really as quick as it is. We can look at the ISACAM security association. We can look at the session to see what's going on. You can see that we're going from our local 10.1.1 to our remote 10.1.1.2. 500 is the ISACAM protocol, UDP. It says it's active. There's the flow information. You can see the source and destination. What else? IPsec. Show crypto IPsec. What else we got? Transform set. So you can see kind of what you configured. You can see what are available. Like if we did nothing, if we did absolutely nothing, just went with the default, it would negotiate AES and SHA HMAC. But we didn't. We went ahead and configured our own. And I think this is probably what we're going to have to see. This is what we're going to see when we do in the lab. And again, you can do show. For example, you can do show IP access list. Have a look at the list that you create. This is the interesting traffic. You can see you're getting some matches, 70 matches there so far, and we can just keep looking at that because there's a ping running, right? So you can see every ping that goes through, it matches that and increments that. So yeah, I think this is the one we're going to see. I think this is the one that's going to be pushed that way. So hopefully that's useful. The second method, the VTI, is unlikely, but I'll do something about that. See what I can put together. All right. Good luck, everyone.